Okay, in this simulation we are going to look at what happens when we adjust the temperature and how that affects the kinetic energy. So in order to keep up with our information, we are going to set up a graph, and for the x-axis we want temperature, and for the y-axis we're going to look at kinetic energy, and we want to look at the average kinetic energy. And we are really anticipating a linear fit, so we'll select that. Alright, so now we have a graph, and basically what happens is we can adjust the temperature here, and then what that does is it affects the kinetic energy of the gas molecules. Right. This particular gas is argon, but the same principle would apply for any gas that we picked. Okay, so we have our temperature reading, which is minus 85 degrees Celsius, and we will take a reading by clicking the red button here. So there's our first reading, and then we'll adjust the temperature up some. So we'll go up to minus 14 and let the molecules stabilize or come to equilibrium, and then we'll take another reading. Okay, and then basically we're just going to repeat this a few more times. So same process there, and then we do the same thing again, and maybe we'll just do one more. Okay, so one more reading. All right. And actually, you see the one there that's a little bit off the line. That's probably because I didn't wait long enough for the system to reach equilibrium. But anyway, I think the same point is going to apply. So now what we want to do is adjust the graph. So in order to do that, we go here, and we're going to make the graph go from minus 300, and we will go up to 800, and we'll change the divisions to 10. And then down here we want to go from 0, we'll go up to 16, and we will make this 7. Alright, so then we'll take a look. Alright, so what we see when we look at the graph is clearly as we decrease the temperature, the kinetic energy also decreases. And then we can ask ourselves the question, well, at what temperature would the average kinetic energy be 0? So when we extrapolate the graph down, that number is actually minus 273 degrees Celsius. So what we do is we start a new temperature scale that we call minus 273 degrees Celsius 0, 0K, and then we work right back up the scale so that 0 Celsius would be 273K.